This is problem 8-121 from section 8.3.1. Now Carlos needs to solve 2x to the third plus 3x squared minus 8x plus 3 equals 0, but his calculator will still only create a standard graph. He sees that the graph of that equation crosses the x-axis at x equals 1. Find all three solutions of the equation. Well, here's already one solution right here. What we need to do is find the other two, and we're going to do that by dividing our whole big equation by a factor of what would represent that x-intercept. Right? So I'm going to do our rectangle stuff, not really just rectangle, but like a grid kind of setup. Okay. And let's actually also add, well, we'll just do that as we go. So what I want to do is I'm going to put my final answer of this big long equation down at the bottom. And I'm going to have my 2x to the third kind of on the outside. Then I'm going to have them going down from there. Plus 3x squared minus 8x plus 3. And I'm going to put in here what I'm dividing by, which is going to be one of my factors. If this is my solution, the factor would be x minus 1. So I'm going to have x and minus 1 right here. Okay? And what we're going to do is work backwards to figure out what becomes inside this box. Okay, so I'm going to draw a little thing right here. And so I know in there, this part right here needs to be this final answer. So this needs to be 2x to the third. Well, now I'm going to work backwards. X times what gives me 2x to the third? 2x squared. Now I can fill out the bottom box, and that's going to be negative 2x squared. And I have another column here. Okay, so the x squared terms, which are in this box and this box, need to add to be positive 3x. So I'm going to need positive 5x squared for those to add up to be positive 3x squared. Okay? In order to make this box be 5x squared, x times blank, which would be 5x, gives me 5x squared. Okay, now I can fill out this part. I'm going in a diagonal pattern, and I'll show you that once we finish up with this. Now I need this thing and this thing to add to be negative 8x, so I need negative 3x. Okay, in order to make that true, the top part needs to be a negative 3. And if I multiply that, I get positive 3, which is right here. If I did not add up to the final value at the end, that means I would have a remainder of something. Okay, so let me just show you the diagonals here. That adds up to this one, this adds up to the negative 8x, and this one's there. Okay, so now I'm going to rewrite this as this big long thing, 2x to the third plus 3x squared minus 8x plus 3 can be made up of the quantity x minus 1 times what we got on the top of our grid, times 2x squared plus 5x minus 3. Okay, so those are equivalent statements. The left side equals the right side. Now I need to solve this side for my zeros, or for my x-intercepts. I already know this one, that's going to be x equals 1. Right, they gave that to us. But now I need to solve this part. And so if we can factor this, that would be the easiest way probably. So I'm going to factor this. I have a 2x here. You can use the box and diamond if you need to factor it that way. But I know it needs to multiply to be negative 6, and it's going to add to be positive 5. So I'm going to have this be negative, this be plus. Now if I set each of those factors equal to 0, I'm going to get x equals positive 1/2 and x equals negative 3. So the question was asking for my roots, I believe, or 3 solutions to the equation. And I know it's a cubic, so there's most likely 3 solutions, as long as one's not a double root. So here are my 3 solutions. We had to divide the big equation by the one root that we already knew to get and solve it for the other 2. Okay, so this is polynomial long division.